Okay, hello everybody. So we are moving into statistics this week, and if that word makes you feel really overwhelmed, it's okay because there's a few different principles or kind of aspects of statistics that you should know, but this does not involve any math, so it's not like a statistics class. As you know, people can major in statistics, so it's a huge topic, but it's important to know a few things about how this topic applies to research in behavioral sciences. So this week we're going to start with descriptive statistics. And just a quick recap from last week. So last week we talked about setting up a research project, selecting your constructs, operationalizing your variables, determining a research design, and then selecting a method of sampling for your research. So this week we're going to talk about, once you have the data, how do you make sense of it? How do we go about interpreting the data? So there's two different kinds of statistics that we use. The first is descriptive statistics, which is statistics that just describe the data. So they kind of lay out all of the information that you have and provide information about the quality of the data that you have, what it looks like, etc. We'll get into that. And then there's inferential statistics. We're going to spend a little bit less time on that because we have so many great resources, software, etc., that we don't need to do stats by hand. So just a couple things we want to make sure we know about that. But inferential statistics, they basically allow us to draw conclusions about the data. So that's where we actually find meaning in the data that we collected. So just to start off, so there's 4 levels of measurement, and it's very important to know when you have your data, what kind of variables you have, or what level of measurement your variables are. So basically, this is how we measure or categorize the data. And this will determine what kinds of tests we can use on the data, what kind of statistical analyses can be used. So just for a quick example, let's say we have a sample of 28 females and we code female as 1. So in our chart, we have all the women, all the female participants are coded 1. And then we have 42 males, and let's say we assign them a category of 2. And then we have 2 gender non-conforming individuals, and let's say that we assign them a category of 3. So we have 1s, 2s, and 3s. If we were to take an average of these numbers, 1, 2, and 3, this would have no meaning whatsoever because the type of variable that this is a category. We're talking about a category of individuals, which is commonly used for various demographics. So there's 2 main levels of measurement. So the first is categorical. So this is data that is nominal. Nominal data is categorized without a rank. So for example, this would be things like gender identity, eye color. There's no better eye color than another eye color. So we're not ranking them in terms of a score or quality. We're simply putting them into categories. And then we have ordinal data. So these are categorized, but there is a rank. So we can think about this as if we're doing or collecting data on income, we might categorize that in a low income section, a medium income section, and then a high income section. So we have those categories and they are ranked. Or you could think of this as a survey. Surveys that you fill out might have a Likert scale, like a strongly disagree, disagree, neutral, agree, strongly agree. Those would all be ranked ordinal data because they have some meaning or some rank to them. Then we have numerical or continuous data. So first we have interval data. These are evenly spaced and ranked, but there's no meaningful 0. So some useful examples here would be temperature in Fahrenheit. So if we have 0 degrees Fahrenheit, it's not like we have no temperature outside. 0 has a different meaning in this scale. It's not an absolute 0. Another example would be a lot of standardized test scores. So if we think about like the SAT or the GMAT, there's usually not a true 0. Like someone completes the test and they get a minimum score of, a couple hundred, for example. So 0 is not, there's no absence of score. And then we have ratio data. These are evenly spaced and ranked, and they do have a meaningful 0. So 0 means something here. So this would be talking about things like weight, height, lengths of time, an odometer reading. So we can have 0 miles per hour would be no speed, the car's not moving, versus 60 miles per hour, the car's moving fast. This is considered a more sophisticated type of data, and it allows for the most flexibility with statistical tests. So more tests can be used here with this type of data. So now that we've talked about levels of measurement, we're going to talk about the 3 main goals of descriptive statistics. So first, we're looking at distributions. What does the data look like? Then we're looking at central tendency. What is a typical score in the data set? And then we want to know about dispersion. How variable is the data? So distributions, we look at things like a frequency table. So this would be a chart that contains numerical values to show how many times a score or value was present in a sample of data. And then we might do something called data visualization. So this is, think of graphs, charts, things like that. It's basically how the data is presented to the audience. And good data visualization should be meaningful. So it should say something about the data in a way that kind of intuitively makes sense when you look at it. So let's look at some examples here. So I pulled these lovely numbers from my dissertation because that was readily available. So for the sample that I looked at, there was 41 individuals. There were 21 females and 20 males. And so that's an example of a frequency table. The categories are laid out, and then here's the number of individuals that fall into those categories. And then I also looked at primary diagnoses. So there were different diagnoses that were found among the archival records that I looked at. You can see the most frequent diagnosis was mild intellectual disability. Some less frequent ones were Down syndrome, Huntington's disease, and a couple of other lower frequency diagnoses as well. But this is presenting the data in frequencies. And you can also see what percent of the sample had Huntington's disease, for example, 2.4%. So now if we look at my little box here, if we look at data visualization, so this is an example of bad visualization. So in the data set we just looked at, we had 21 females and 20 males. And this chart is rather misleading. I'm sure you can think of why that might be. But basically the axis is not spread out enough. So the numbers are really in very small increments. And so it looks like there's a big difference between female participants, the amount of women that were in the study versus men that were in the study. But that is not accurate. So this would be a better example of data visualization here, a pie chart. So we can see that there's slightly more females in the study than males, but it's almost equal. So we have another bad example of data visualization. So I pulled this from a Medium article. This is caffeine ratings for various teas that this company provides. And as you can see on the x-axis there at the bottom, that horizontal axis, it's pretty wonky. We go from 0 to 1 milligram, then jump up to 19 milligrams, and then 20 milligrams. There's no regular interval that we're looking at here. So it's hard to make a lot of meaning out of these caffeine ratings when the scale is so not well proportioned. So now I want to talk about measures of central tendency. So this is mean, median, and mode. And these might sound familiar to you, but just as a refresher, So the mean is the sum of all of the values divided by the number of values. It's sometimes called the arithmetic mean. The median is the middle value. So if we were to line all of the values up and go with the middle number, that would be the median. If there's no middle number, the arithmetic mean of the two middle numbers would be used to derive the median. And then we have the mode, and that's the most common value that we see. So here's an example. So we have statistics student test scores. This is completely fictional data. So we have our frequency table there on the left-hand side. We have a number of students that got various scores, and we had 4 students that got a 90%, 2 students got a 95%, and then we have some variability there. There's a large spread of scores. So if we look at this chart here, we see that most of the students got a 90% on their test, on their final. So that would be the mode. Most of the students received a 90%. That's the highest number. The median is actually similar. When you line up all of the numbers, it's also 90. So those two are similar values. But if we look at the mean, this number is much lower. It is almost 10 points lower, 8 points. Maybe that's an exaggeration. It's quite a bit lower though. So we go from an A- here to a B-. And the reason why the mean is so low is because it is being pulled down by these outliers, this 40%, 66%, that's really kind of heavy on the lower grade side over here, these individuals that are kind of outliers. Those individuals are pulling that mean down because remember, the mean relies on a sum of all of the values and then divided by the number of values. So the mean is going to be most affected by outliers. So if we look at this example, looking at measures of central tendency for average income among various professions, we have, again, a big spread. On the lower end, we have $48,000 a year. On the very high end, we have $250,000 a year. So again, we see that the mean is being kind of persuaded by that or pulled by that higher number, that 250,000. And the median is a more accurate representation here. And so when we look at data like salaries or average household income, things like that, the median is often a better representation of what the data actually look like. So next we're going to talk about dispersion. So this is really concerning how much variability there is among scores. These include, or this area includes things like standard deviation, outliers, and then skewness and kurtosis, which we'll talk about. So first, just to go over this example here, back to this example of the average salaries with various professions. So we want to know about the dispersion here. So we would look at 2 indicators. We have the range, which is the difference between the highest and the lowest values. And then we have the standard deviation. This is the standard amount that any given value kind of strays from the mean. So how far apart are the other values from that middle, from that measure of central tendency? So in this case, the range is 202,000, which is a huge range for our salaries. And the standard deviation is approximately $55,000, which again is a huge variation here. So we know we have a wide spread here of salaries. When we look at data distribution, we can have kind of different patterns of distribution. So we have here what's called a bell curve, and this is going to be parametric data. This is when the mean, the median, and the mode are all following kind of the same line right here in the middle. So it's even on both sides, very symmetrical on both sides. Over here, we have what's called a positive skew. So the scores are pulling that mean in this direction, in the positive direction, pulling it forward, if you want to think of it that way. So the mode in a positive skew is going to be the lowest value. The median is going to be the second lowest, and the mean is going to be the highest value, because remember that mean is being pulled toward these outliers here on this end. And then opposite to that, in a negative skew, we have the mean being pulled in this negative direction toward these lower scores over here. So in this case, the mean is going to be the lowest score, the median is going to be in the middle, and the mode is going to be the biggest score in this case. So as we just talked about with skewness, positive skew, there's going to be outliers on the extreme high end. With a negative skew, there's going to be outliers on the extreme low end. And skewness will impact which measure of central tendency is most informative. So if we go back here, mean is probably not going to be as informative as a median or even the mode in this situation, because it's being so influenced by these outliers. And just real quick, you'll hear these terms. There's parametric versus non-parametric data. Parametric simply means that the data is evenly distributed. So in other words, it follows that nice bell curve. It's symmetrical. This allows for more powerful statistical analyses. More of the common kind of statistical tests that you'll see are going to be parametric tests. Non-parametric data could include categorical data, so nominal or ordinal data, as well as interval or ratio data that is not normatively distributed. So it might be skewed. There might be a lot of outliers. So this allows for less statistical tests that are available. They tend to be less powerful because the data is not ideal, if that makes sense. So the conclusions that we draw from the data are also not going to be ideal. Then we have what's called kurtosis. So kurtosis refers to kind of the spread of scores. And so data with a low standard deviation is going to have a high kurtosis and vice versa. Hint, hint, this is on the quiz. So as you can see here with this visual, this kind of tallest curve has a very positive, a very high kurtosis. In the middle here, we have a normal distribution. So the scores have that nice kind of bell curve. And then here at the bottom, we have a negative kurtosis below that bell curve. This means that there's a big spread and there is not a high mode in this situation. With this line, we have a very high mode. That mode is going to say, this is where most of the people fall. So just real quick to test your knowledge, looking at this positively skewed, this graph here, where would you place the mean, median, and mode along these lines here? Which is going to be the smallest number, and which is going to be the highest number, and which will be in the middle? I'll give you a second. All right, so this is positively skewed. I spoiled that, but it is a positively skewed distribution here. And so in that case, our mode is going to be the most frequently seen value. So that's going to be this highest point here. Our median is going to be in the middle, and our mean is going to be the highest number that's being pulled all the way right here with these higher value outliers. All right, so that wraps up our lecture on descriptive statistics. And so we will now talk about inferential statistics in the next lecture.